Good afternoon, student. Today's topic is reflection of light. Refraction of light. Refraction of light. Definition is the phenomena of the change in the path of light as it passes obliquely from one transparent medium to another is called refraction of light. Then refraction of light is again the phenomena of the change in the path of light as it passes obliquely from one transparent medium to another is called refraction of light. For this, we draw a diagram for support of this definition. Now this is a medium. Which one? ये medium 1, this one is medium 2. A rays of light incident at point P. This is called incident ray. Draw a normal and this rays is reflected and this called is reflected rays, and this one is called angle of incidence and this one is called angle of refraction, where medium is considered as first one is denser, second one is rare. Now the condition is the relation between angle of incidence and angle of reflection. फर्स्ट केसेस में आएगा when फर्स्ट वन कि मीडियम 1 is rare and medium 2 is denser. Then that means I greater than R. Second condition, M2 is rarer and M1 is denser. Then relation is I is less than R. Now laws of refraction of light. Laws of refraction of light. First one, the incident ray the refracted ray and the normal to the interference. Interface at the point of incidence. Point of incidence all lie in the same plane. Second one, the ratio of the sine of angle of incidence and the sine of angle of refraction is a constant for a given medium. That is sin I divided by sin R equals to constant, or it can be written as sin I divided by sin R equals to n, where n is a constant, is known as refractive index of the medium. Now the topic is refracting index. Refractive index. The definition is the refractive index of a medium. The refractive index of a medium for a light of the given wavelength may be defined as the ratio of the speed of light in vacuum to its speed in that medium. That is refractive index I equals to. That is refractive index I equals to speed of light in vacuum divided by speed of light in medium. In variable terms, Ri, or it can be written as N, C divided by V. Now next topic is principle of reversibility of light, which is based on refraction. Fourth topic, principle of reversibility. Reversibility of light. For this, we write down the definition of this principle. The principle states that if the final path, if the final path of light path of a ray of light after it has suffered several reflection and refraction is reversed. It retraces its path exactly. Retrace its path exactly. That means if a ray is going in a forward direction and faces are suffered a several reflection and reflection, then after final condition it retrace on your path. It means जिस रूट से गई उसी रूट से बैकवर्ड हो जाएगी, तो उसे कहते हैं रिवर्स प्रिंसिपल ऑफ रिवर्सिबिलिटी ऑफ लाइट. फॉर दिस वी ड्रॉ a ray diagram. This is the boundary of two medium x and y. Consider this one is rare medium 1 consider कर दिए. This one is denser medium 2 consider कर लीजिए. Now a ray incident on a point B. This called is incident ray. Draw the normal, and this one is angle of incidence, and the rays reflected. A rays going from rare to denser, then in these terms I greater than R. Let us put a hindrance or plane mirror in the path of reflected rays. Then the rays is this point पर reflected and retrace your own path as it is going forward in a reflection. Then after this one point reflection, it retrace your own path. Now this is proved in mathematical terms. First one, this is the normal n and this one is n dash. Now for proof, angle of incidence that means angle ए बी और ये एन इक्वल टू कितना आ गया आई, एंड दिस पॉइंट इज सी. एंड एंगल ऑफ रिफ्रैक्शन एंगल सी बी एन dash equals to R. Now consider from Snell's law or definition of refractive index or second laws of refraction. It is also called Snell's law. By Snell's law, it means sin I divided by sin R equals to, now refractive index is given right in terms of n. It is also right in terms of our rays going from medium 1 to medium 2. Equation number 1. Now when a ray of light incident on plane mirror, then angle of incidence angle C B N dash equals to R, and angle of refraction angle ए बी एन इक्वल्स टू कितना आई, अगेन बाय स्नेल्स लॉ। एंगल ऑफ इंसिडेंस यानी एंगल आर डिवाइड बाय एंगल ऑफ रिफ्रैक्शन इक्वल्स टू दिस वन इज कॉल्ड एज म्यू 2 म्यू 1, इक्वेशन नंबर 2। Equation number 2 now multiplied by equation 1 into 2, that means sin I divided by sin R, multiple sin R divided by sin I, that means 1 mu 2 multiple 2 mu 1, this is cancel out, it means 1 mu 2 multiple 2 mu 1, that means it can be written as 1 mu 2 equal 1 divided by 2 mu 1, that means this mathematical term shows a rays a medium changes one rays for going from 1 to 2 and this one going from 2 to 1, that means a rays are traveling in a forward direction. After reflection it becomes the same route when a ray is going from starting. This topic is completed. Now new topic, refraction through a rectangular glass slab and lateral shift, which it depends on previous topics, or refraction of light. Topic is refraction through a rectangular glass slab and lateral shift. For this purpose we draw again a ray diagram. This one is the boundary of medium 1 to PQ. A ray incident on a point B. Draw the normal, and this one is angle of incidence and this one is angle of refraction, because this one is rare and this one is denser, and this one is angle of refraction. Again draw another boundary of when a rays again going outwards from denser medium. This one boundary is considered as S and R, and this reflected incident on point C. Again draw a normal, and this one is working as इसे I1 कंसिडर करिए, ये I2 कंसिडरेशन आएगा, and this one ray is this time away from the normal because a ray is going from denser to rare. Now we draw a ray diagram. If a ray is not reflected by any medium, this is represented by this one. Draw this one is called as lateral displacement or lateral shift. This perpendicular distance, lateral shift or lateral displacement. Now solution of this lateral shift or this topic by Snell's law. By Snell's law, where at the boundary of a phase PQ, when a ray is going from rare to denser, that's when angle of incidence divided by angle of refraction equivalent, and this one is going from rare to denser. This medium is considered as air, and this medium is considered as water. Then this one is A, nu and दिस वन इज ग्लास स्लैब है ना, ये गलत हो गया, यहाँ लिखिए ग्लास मीडियम है, जी कंसिडरेशन है, एम यू जी आ गया। इक्वेशन नंबर 1 लिखेंगे अगेन बाय स्नेल्स लॉ at face S and R, and this one is angle of incidence sin I2 divided by sin, again using Snell's law, at face SR sin I2 divided by sin R2 equivalent होगा, this time is going for glass to air, equation number 2. Now multiply equation number 1 and 2, multiply equation number 1 and equation number 2, what we gain, sin I1 divided by sin R1 multiple sin I2 divided by sin R2, and this one is A mu G into G mu A, and what will this one is equals to by principle of reversibility as we shown, सेंस लिख दीजिए। वी आर कंसिडर ऑलरेडी डिस्कस कि 1 म्यू 2 इक्वल्स टू होता है 1 डिवाइड बाय 2 म्यू 1, दैट मीन्स 1 म्यू 2 मल्टीपल 2 म्यू 1 इक्वल्स टू वैल्यू होगी 1, इट मीन दिस वैल्यू इज 1, इट मीन्स साइन I1 डिवाइड बाय साइन R1, साइन I1 डिवाइड बाय साइन R1 और साइन I2 डिवाइड बाय साइन R2 इक्वलेंट आएगा वैल्यू 1। हेंस और इट मे बी कंसिडर इट इज ओनली पॉसिबल कि साइन I1 इक्वल्स टू आएगा साइन R2 और I1 equals to R2, where why? For this we taking the two parallel rays taking at PQ parallel SR, that means angle of incidence यानी I2 इक्वलेंट होगा R1, सब्स्टिट्यूट द वैल्यू ऑफ I2 इक्वल्स टू R1 इन क्वेश्चन नंबर 3, दैट मीन्स साइन I1 डिवाइड बाय साइन R1, नो चेंजेस, साइन I2 डिवाइड बाय, सब्स्टिट्यूट द वैल्यू ऑफ I2 इन प्लेसेस ऑफ R1, एंड दिस वन इज साइन R2, question number equivalent value 1 के। As we know PQ parallel SR, it means angle of alternate angle equivalent I2 equivalent R1, I2 equivalent R1, then the value of I2 in equation number 3, sin I1 divided by sin R1 sin R1 divided by sin I2, that means sin I1 divided by sin R2 equals to 1, this imply sin I1 equals to sin R2, it is possible only I1 equals to R2, this is called, now I1 equals to R2, this shown that angle of incidence is equal, this is shown that angle of incidence is I1 equals to R2, then the lateral shift is considered as, according to definition of refracting the lateral shift, then hence lateral shift is the perpendicular distance, lateral shift is the perpendicular distance between the incident ray and emergent rays when light is incident obliquely. On a refracting slab with two parallel faces. That topic is completed.